This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Are you a software engineer, developer, consultant, architect, manager? No matter what your role is, we want to hear from you. Please take a minute to complete our listener survey to help us make SE Radio even more relevant to you. Just go to se-radio.net/survey2023 to share it with us. That's se-radio.net/survey2023. Thanks for your support of the show.
Welcome to Software Engineering Radio. I'm your host, Gregory Kapfhammer. Today's guest is Zach Lloyd, the founder and CEO of Warp, a startup dedicated to helping software engineers quickly create great software. Prior to Warp, Zach was a principal engineer at Google, working on Google Docs, Sheets, and Slides. He was also the interim CTO of Time and the CTO and co-founder of a startup called Selfmade. Zach, welcome to Software Engineering Radio.
Thank you for having me here, Gregory. Excited to chat today.
So today we're going to be talking about the Warp command line terminal. I'm really excited about a lot of the cool features that are in the Warp terminal, and I really look forward to diving into them. With that said, I hope that you can share a few of the key features that the Warp terminal provides, and then explain why you decided to build it.
Sure. So the short answer is we decided to build it because the terminal is I think a very important tool to a lot of developers. Most developers, it's something that they use every day, but it's also something that hasn't really been rethought or explored from first principles, I think almost ever. Like the version of the terminal developers use today is basically identical to what they've used for the last 40 years. And from a usability perspective, we thought that there were ways we could improve upon it. So some of the big improvements that users will see right out of the gate is when you use Warp, we actually put structure around the output in the terminal. So we have this concept called blocks. So when you run a terminal command, we group the command and its output together into a block, and you can navigate your terminal on a sort of command by command basis. And you can take easy actions on those like copy, paste. You can search just within one command's output. Any command's output you can easily share. So that's one big thing that people will notice. And then another big thing is the way that input works in Warp is very different from a normal terminal. So in a normal terminal, the mouse doesn't work, for example. And so in Warp, the terminal input works a lot more like how a code editor works, like VS Code or something like that. So you get things like syntax highlighting, you get command completions out of the box. It's fully mouse accessible. And so those were two of the really like key user experience things that we launched with. And then there's also a whole bunch more that I hope we get to talk about. But yeah, those are some of the basics.
Okay. So it sounds like Warp has a lot of cool features that standard terminal windows don't have. Before we start unpacking the many technical innovations that are in Warp, I'm hoping we can define some key concepts. So let's start with terms like console, terminal, command line, and shell. Zach, can you dive in and give us a brief definition of those types of terms?
Sure. So they're all related. So console typically means the actual sort of hardware terminal, I guess, which is maybe the starting spot. Typically when people are using a terminal, what they're actually using is a terminal emulator, which is like a actual GUI app that you run. Could be you running it on your Mac, your Linux, Windows. And what that app does is actually emulating the behavior of the physical piece of hardware that people used to regularly use. And so the terminal has the window, and it has it's basically like a character rendering device and a character input output device. So it's the program that takes input from your keyboard, one character at a time, and then sends it actually to the shell, which is another one of the terms you're mentioning. The shell is basically like the actual command interpreter. So the input to the shell is text. It parses that text. It figures out what command that text's launching, and then the shell launches applications. It then takes the output of those applications, which again, if you're in this command line environment, are character-based, and sends them back to the terminal. And the terminal is responsible for rendering the characters on the screen. So at really simple level, it's like the terminal is where the characters are rendered and the characters go into the shell. The shell is what understands those, executes programs, and returns them back. And then the final term you mentioned is the command line, which I think is kind of more colloquially like the whole interface around doing these text-based apps, or at least that's how I think of it. So sometimes you'll just talk about the command line. I'm developing a command line app, and what that means is it's an app that runs with a text-based interface. So it runs through the terminal and shell. Does that make sense?
Yeah, that makes a lot of sense. I want to pick up on two things that you've said so far. First, you mentioned that terminals have been around for decades. And second, I heard you frequently talking about how terminals are text-based in nature. Can you comment quickly? Why are text-based terminals so exciting and powerful for developers to use?
Yeah, it's a great question because there aren't many other 40-year-old apps that people still regularly use. What I would say is that terminals and text-based apps have a bunch of inherent like advantages compared to other types of apps. So, for one thing, they're the easiest type of app to write in a lot of ways. Like most developers' first app that they write, their hello world, is something that outputs text to a terminal. After that, it's just very easy to process text as an input. So it's like there's the standard format of like, I forget what it is, like argv and argc. If you're writing a C app, it's like it just passes in the parameters via text. Is just a much easier way to take data input than to write something that handles like mouse events and renders a rich UI. So there's this advantage of these apps being easy to write. I think a second advantage is like they're very fast to run and they're very lightweight. If you're a developer who likes to use the keyboard a lot, it's sort of a lightweight execution environment for running these apps. There's even more. So from like a UI surface standpoint, I think it's very easy to write a command line app that is sort of infinitely configurable just in terms of flags. Whereas you start to run into the limits of what you can do with a GUI app. You have to make a lot of choices around like, are you going to have this button or that button, this form or that form? In a command line app, like it's effectively infinite. You can just keep adding flags. So there's that value. There's the value in terms of these apps, like text being a sort of universal interface where you can take the output of one of these command line apps and very easily pipe it as the input to another one. And so these apps are sort of naturally composable. And you see this with like Unix pipelines. It's a really powerful concept for how do you define like very minimal apps that work well together. Just having text as the interface is really good for that. And then I would say one final thing is like a lot of the way the internet works, a lot of what's like running internet servers, when you think about it, are things that are like, Docker containers that are essentially running a bunch of command line apps. And those servers, they don't really have like, they're not actually running GUIs. And so if you want to interact with them, you sort of need to be using a command line interface. I know that was a lot, but I do think there's a lot of these inherent advantages to using text as the interface that make this interface still super relevant for developers today. And it's a ubiquitous tool every developer uses.
Yeah, I really resonated with what you said. For me, the command line terminal is also super relevant, and I use it in a wide variety of different workflows. Could you share with us what are some common workflows that you adopt when you're using a command line terminal?
It's a great question. So it's a really, really flexible tool. It's almost like I sometimes use the analogy of a spreadsheet for knowledge workers. Like you can do so many different things with it. I would say just to name a few very common ones. So people will do a lot of like source code management is very common. Some developers, it's still popular as an editor. So people will still actually run like Vim and Emacs and use the terminal for that. Attaching to remote machines is a very popular thing. So it's like terminal, like I said, if you want to access a server in production or do some sort of debugging on like a Raspberry Pi, like typically those machines will not have GUIs. And so you'll use the terminal for that. Internal tooling. So for developers, like I would say command line apps are still the most popular by far way of writing internal tools and scripts. And so that could be whatever a company wants to do. It could be like pulling information for data analysis. It could be orchestrating, GitHub actions and different workflows. Like that always starts with work in the terminal. And so I guess one other thing is like a lot of companies that are cloud providers will build and ship CLIs as one of the primary ways for doing interactive work with whatever their cloud thing is. So like G Cloud or AWS, a lot of if you're going to do interactive work is done through the terminal.
So you mentioned many of the ways that I use a terminal on a regular basis. In fact, I even use a terminal to edit all of my text because I use a command line tool to edit text like NeoVim or Emacs.
Yep, exactly.
So with those things in mind, before we start talking about the specifics of Warp, there may be some developers who are listening who don't normally use a command line terminal. So can you tell us a little bit, what steps would a developer normally take if they want to download and install and set up and configure a command line terminal?
Yep. So depends on what platform you're on. So typically the platforms will actually ship with a default terminal. Like if you're on Mac, there's the terminal app. If you're on, I think most Linux machines will ship with a default console. But that's like a very, very bare bones experience, I would say. So if you want to get it to a point where you have like a more ergonomic or efficient experience, you're typically going to download and install a third-party terminal. There's different ones that are popular on different platforms. On Mac, there's not just Warp, but there's iTerm. There's some other terminals I think we'll talk about later, like Alacrity and WesTerm. So there's a variety. So the first step is to choose what terminal you want to use. And then depending on like the terminal, there's typically a bunch of setup that you then go and do in your shell, and actually, and maybe in the terminal too. So you might want to choose a theme. There's a lot of open source stuff out there that'll make your shell experience better. This is particularly relevant if you're not using Warp. Like in Warp, one of the things that we try to do is actually really minimize the amount of config that you need to make the terminal usable. But if you're using a standard terminal, you might want to like install something that helps with auto completions or helps with themes, or you might want to change your shell. Like often the default shell might be Bash, but you might want ZSH or Fish. And so there's a bunch of configuration to do to figure out like, how do I make this thing usable for me? You might want to change your prompt. Like that's a very common thing people do so they can see what their current context is before they run a command. So, and then there's tons of resources on the internet, and like, honestly, some of the most popular open source projects on GitHub in terms of stars are things about making your terminal better. So there is a ton of information out there if you want to like, get a terminal going and then set it up. I guess one other thing I didn't mention is like IDEs will often ship with a default terminal. So that's another option. So if you're using like, VS Code or one of the JetBrains things, there's an inbuilt terminal that comes with it. Although if you want to get, my personal preference, and people will vary on this, is to have a dedicated terminal app, but you can also use it within the IDE.
So thanks for your responses. I think you've done an awesome job at setting the stage. Let's dive into some of the basic features that are provided by the Warp command line terminal. A moment ago, you talked about something like Bash, which is a shell. Does Warp provide its own shell, or does Warp integrate with other shells like Bash? Can you give us a few more details?
Yes. So as of today, Warp does not have its own shell. Warp is compatible with Bash, ZSH, and Fish, which I think are probably the three most prevalent shells in use these days. There are other shells that are a little bit less frequently used that we could support but don't currently support. And the general experience with Warp is that if you download it, open it up, it will use your default shell config and hopefully like basically just work without you having to do any extra work to get it set up to work with your shell.
So the features that you've described in Warp sound really cool. What steps would a developer take if they want to install the Warp terminal? Do they go to Warp.dev? Do they use Homebrew? Do they take some other approach? Can you give us some more details, Zach?
So those two options are exactly right. So you can go to Warp.dev and you can download the DMG and install it like you would any other Mac app. Or if you want to use Brew, it's simple too. It's brew install --cask space Warp. And that will also install Warp just like any other Brew formula.
Okay, so I know some developers may already be using their own terminal window, and they may have even adopted the use of something called a terminal multiplexer, like Screen or Tmux. As we do more of a deep dive into Warp, does it provide its own terminal multiplexer, or does it integrate with existing multiplexers? How does that work, Zach?
As a Warp user, you have a couple choices. And just to sort of describe what a terminal multiplexer is, maybe for a second. So a terminal multiplexer like Tmux it basically lets you do things like session management and pane management within a terminal window. which is useful if you want to sort of multitask across different terminal sessions. And so for Warp, the short answer is you can use tmux or you can use screen. If you use them, though, you currently lose a bunch of the stuff that makes Warp like different as a terminal. So you sort of fall back to the behavior of a traditional terminal where you don't get blocks or input editor. So it's not an awesome experience, just to be honest. We're trying to figure out how to make it better. The other option, if you want that type of functionality, is you don't have to use a multiplexer. Like Warp, it natively supports having split panes and tabs and multiple sessions that you can view at once within the terminal. But it doesn't yet support some of the more advanced functionality that tmux has around session management. And it's actually, I think it's one of our top 10 issues on GitHub to offer better support for that.
Okay, so that sounds really interesting. You've mentioned on more than one occasion the idea of the command block feature that Warp provides. And I'm understanding that that feature would be turned off if I used tmux. But let's say I wasn't using tmux. Can you tell me a little bit about what the command block feature is and how it works?
Sure. So the basic idea is that most, not all, but most of the way that people use the terminal is as a sort of REPL, so like a read eval print loop. And what that means is like you're either in the state of like entering a command, or actually after you enter a command, it tends to produce some output. And in most terminals, the terminal just has no sense or understanding of what the structure of the underlying session is. So the terminal will typically have, when you run a command, it's just like filling up a buffer of text. And there's no like demarcation between what command is attached to what text. It's just one big buffer. And so, for instance, if you want to do something like copy the output of one of your prior commands in a normal terminal, you have to sort of take your mouse and select and scroll to just the right region and capture just the right characters, and then you copy it. And same thing if you want to like do anything that is like oriented around a single command's output, that is very hard in a normal terminal. In Warp, what we do is we automatically understand a little bit more of the structure of what's happening. And so essentially, if you were to look in the UI, we group a command with the output that it generates. And that gives you some really nice sort of UX benefits around things like I can very easily navigate my command, my scroll history a command at a time, for instance. If I want to scroll right to the start of a command or right to the end of a command's output, I can do that. If I want to search just within one command's output, I can trivially do that. And that's really useful if you're like running the same command over and over again, but just want to search for a log message in like the last version of it. If I want to share something I did, we have like a native sharing feature that's based on blocks. So you can easily get like essentially like a gist or a permalink to anything you did in the terminal, and you can send it to people on your team. And so the way I view this is as like a new UX primitive, almost similar to like the block style thing that you would get in a Jupyter notebook or another like structured document format that makes, working with terminal outputs, I think just like a lot more effective and productive.
Yeah, I'm glad you said Jupyter Notebook, because in fact, that's something that I thought of when I was using the command block feature in Warp. Can you give us a concrete example? How would a command block help me if, for example, I was testing or debugging my program? How would I use blocks?
A good example would be like, let's say you're doing successive runs of the same command. It's producing different log output each time. And you want to just search in the most recent invocation of that command's output to see if a certain debugging string is there. So what you do is every block we have has like a little header, and you would just like sort of right click and be like, okay, I want to search within the contents of this block. And then your search is automatically scoped to the last command invocation. And then going further, let's say, okay, I can't figure out what's going on here. So let me see if someone else can look at this debug output who I'm working with. With one click, you can grab a link to the block, send it to your teammate who can look at the output in their browser. They don't even have to install Warp. And maybe they can tell you, oh, I see what's going on. Like this is what you need to do to debug it further. And so that's like an example of how having that extra structure can be really helpful when working with terminal outputs.
Yeah, I can see that being super useful to be able to share the output of a specific block with a member of my team and say, hey, can you figure out why this test case is failing? That would be something I would really want to be able to do as a developer.
Yeah, it's cool.
So I know that you mentioned before the idea of a session management, and you talked about various window management features that Warp has. Can we do a deep dive into session and window management? What kinds of features does Warp have in that area? And then how does it compare to the similar terminals that might maybe, for example, come on Mac OS?
We offer, I guess there's two big features in Warp. So one is multi-tabs. And so, if you were to look back at terminals, I don't know, 10, 20 years ago, it was just like you had a single terminal window that you worked in. Within Warp, you have the ability to have multiple sessions and switch between them. And the ways that you can switch between or create new sessions in Warp is at the window level. So you can always do Command N and get a whole new terminal window. And some users like to work like that. Within a window, you could have tabs. And so think of like Chrome tabs, essentially, where each tab is a single terminal session. Or within a tab, you can have split panes. And so you can actually have side-by-side sessions. I wouldn't say there's anything like particularly groundbreaking about Warp, at least right now in this respect. It's like sort of on a par with some of the other terminals on Mac that ship with this type of session management. It is all keyboard accessible. So it's like if you want to quickly navigate between ones or others, you can do that. We have another feature that's actually pretty cool and popular, which is something that we call, the official name is like a hotkey window, but the colloquial name is a Quake mode window. And what that does is it lets you assign a sort of global keyboard shortcut, which no matter what application you're using, you have the ability to get like a Warp terminal to sort of modally pop up in front of you. And it's called this because I think in the video game Quake, there was this sort of same terminal that you could pull up anywhere. And so we have that too. So yeah, those are some of the cool like window and tab management functions that we have in Warp right now.
Yeah, I'm familiar with the feature that you talked about, and I have to say it is cool to be able to have a Warp terminal zoom in regardless of the program that I'm currently using. So in summary, we said that, like, for example, you could have maybe one pane in Warp that is related to testing, and I could have another pane that's related to running a compiler, and I could have another one of the panes that was related to, like, for example, running a server or something of that nature. Are there any limits in terms of the way that I lay out my panes or lay out my tabs, or is Warp configurable in that fashion?
It's totally configurable. And then we have actually one other thing, which I should have mentioned, which is this concept of a launch configuration. And so you can actually create a YAML file, which says, I think your example is a good one. It's like, hey, I know that when I'm working on this project, I always want one window for the client. I want one window for the server. I want one window for connecting to production. So you can define that in a file, and then you can launch that configuration as sort of like one atomic thing so that you can quickly get the setup that you want.
Okay, so is there a way, for example, that I can have one setup when I'm building one program and another setup when I'm building another program?
100%. Yeah. And you can define those as like two separate launch configuration files. And then, in Warp, we have this feature called the command palette, which you can push Command P wherever you are. And one of the options from there is launching one of these launch configurations, and it will just bring up a window that has the exact panes, sizes, programs running that you want, so that you can waste less time getting set up and you can context switch much more easily.
That sounds really cool. So we've talked about a number of the key features that Warp provides. I remember a while ago you talked about the idea of Warp offering a completion menu. What is a completion menu, and how does a developer use it?
Yeah, so I'd say the command line has a bunch of awesome attributes around its UX being very fast and extensible. But one of the challenges around the command line UX is like, you have to remember how these infinitely flexible commands are actually used. And so documentation and discoverability around how to use commands is a challenge for this kind of interface. So one of the things that we offer is we help you complete commands. And command completion is a standard shell feature that you will see in all sorts of shells, but in Warp, it's actually quite different because we've implemented it at the level of the terminal. And what that means is like you get essentially a visual completion menu, which, if you're an IDE user, if you use VS Code or JetBrains, will be familiar with you. And so we're able to, as you like start typing a command, if you push tab, and you can configure this, but as you push tab, we bring up these visual completion menus, which give you an ordered set of our best guess. at what the next thing that you might want to enter is. So if you do like git space and then hit tab, you get options of like all the git commands. If you start typing ch, then it filters down to like git checkout. So it filters as you type to the most likely suggestion. And then another sort of unique thing about Warp that we offer that other terminals don't offer is we give you actual documentation as you type around what these commands mean. And so if you have something with like obscure flags and you're like, remind me what -- force does or something like that, then we can actually in line show you, okay, this is what this flag means. And you can bring that documentation back up whenever you want it too. So if you can position the cursor and hit Command I and you'll get the documentation, you can hover and get that same documentation. And so, I mean, to my knowledge, a totally unique feature at the terminal level in Warp. And so that's I think a real user advantage. And then you don't have to configure this in Warp either. So, typically if you want completions, and I think Git's a good example, you have to put something in your RC file in like one of your startup files that will source those completions and make the shell aware of them so they're available. In Warp, all this stuff just ships out of the box, which is very nice.
So the features you're describing sound really useful. If I am already using, for example, Fish, and Fish provides completion, does that completion work alongside of the completion that Warp provides? How does that work?
So Warp typically takes it over. And this is I would say it's a trade-off. So we try to do the best that we can shipping out of the box with completion. And we ship with like 400 or 500 tools. I forget the exact number. But if you've configured things at the shell level, because in Warp, we sort of take over the entire shell input editor, we aren't able to use those completions. It's a thing that we've like considered, like, and this is maybe getting technically in the weeds of like, is there a way to use the shell's completions with acceptable sort of performance characteristics and mix them in with our own? The Warp ones tend to be super, super low latency because it's all like natively bundled into our app. Whereas when you've kind of like go out to the shell for questions, it becomes a little bit slower. And then the shell ones don't have the same spec format as ours. Like they don't give you documentation. And so, as of right now, this is a real trade-off. And it's definitely something that users of Warp give us feedback on. And we're trying to figure out what is the best possible solution, but it's a great question.
Okay, so right now it seems like Warp basically takes over your command line completion. If I start running a text editor inside of my Warp terminal window, does it also take over the completion of NeoVim or Emacs? What happens in that case?
In that case, everything works just as it normally would. So in general, and again, this will be a little bit technical, but I think that's okay. Like there's a couple modes of running the terminal. There's the REPL mode where, Warp is providing the command line editor and doing things like completions. And then there's the mode that you go into when you run an app like Vim or Emacs, which is actually using a different character buffer, which we call it the alt grid or the alt screen. And in those types of apps, good examples like Vim, Emacs, Top, those fully interactive like TUI, like text user interface based apps, Warp's behavior is exactly the same as a normal terminal. And so, a lot of people use Vim plus Warp, Emacs plus Warp, and that all just works exactly as you would expect it to.
Okay, that makes a lot of sense. I often do development of my own command line applications. So if I'm using the Go programming language or Python, and I'm building my own command line interface, does Warp integrate with it in terms of providing completion of its command line arguments?
So, sort of. The way that works is there's an open source repo that we use that has the specs for all of these different completions. It's actually run by another startup, which is called Fig, where they've defined a spec it's in JSON, and it gives you like the ability to say like, okay, here's what this command looks like. Here are all the flags. Here's what they mean. We then take that repo and translate it into something that we can use, which is in Rust. If you want to support new tools, at least for now, until we have a sort of more fleshed out solution on the Warp side, what you would do is you would make a submission to that repo and it would eventually make it into Warp. The longer term solution for us is to actually create a sort of spec where you don't have to publicly publish your command line. Like a lot of use cases for this type of thing are people's internal tools or private tools. And I think the right solution is something like there is a spec that you can publish and just limit the scope of without putting it out fully open source into the world, and maybe just use it yourself, even if you want. And that's something that's on our roadmap to actually this coming quarter, we're going to be working on the start of this.
Yeah, what you're describing would be really helpful to me as a terminal window because I've implemented a bunch of my own programs and they're not in that repo. And I may not even want to publish the details about my own programs. So if there was a way that I could make Warp aware of my own command line applications, that would really be awesome.
That's 100% how it should work. And that's on our roadmap. We're just not quite there yet.
Okay, so we've talked about a lot of the features that Warp provides, and I want to dive into some of the more advanced features of the Warp command line terminal. So there's a whole bunch that I'd like to talk about, but let's start with the ways in which Warp uses the GPU, or the graphics processing unit. Can you talk a little bit about why your terminal uses the GPU, and what are the benefits associated with using a GPU?
The primary reason that we use the GPU is performance. When you're a developer using the terminal, there's a lot of reasons why you might want to use the terminal. But one of the things I think that's absolutely essential is that the terminal performs really, really well. And you can think of different dimensions of performance. Like there's a dimension of just like pure input output operations. So that's like how quickly do characters go from the terminal into the shell, and then more importantly, typically from a shell program back into the terminal. But there's also a big performance that I would think of more in terms of graphics performance, almost things that like if you're a video game developer, you might care about. So it's like, what's the frame rate at which we can render terminal changes, and like how fast can you scroll around your terminal? And these are, operations that become really important if you're doing things that work with a lot of text. The sort of non-GPU way of doing it is using a more like CPU or software-based rendering framework. The performance of the GPU-based way of doing it is certainly better. What it means for, a terminal like Warp is that we are interfacing directly with the graphics APIs on Mac. And what that looks like is that you're actually, you're writing code in a shader language. On Mac, it's the shader language is Metal, which is somewhat similar to like OpenGL. And it's a very different style of programming. You're basically writing graphics operations that have to be able to run, in parallel, and you're running shader code that gets shipped to a GPU. But yeah, the basic, long-winded answer here is like, it's faster.
Okay, so it's faster, and I'm assuming it's faster from the perspective of user perceived latency.
Yes.
When you use the GPU for doing the rendering of text in the Warp terminal, does it also reduce things like the system load? How does it work in terms of things beyond user perceived latency?
So I think user perceived latency is the biggest one. I haven't written a text rendering thing that uses the CPU, so it's a little bit hard for me to sort of compare what it would be like. But in general, I think we're doing it in the most efficient way, because it is not like pegging the CPU and pegging system load as you do this. It's doing it on a totally different piece of hardware. And yeah, I mean, these are like generally, I think this is the most efficient way that you can do the graphic stuff, is by going directly to the GPU and not forcing your CPU to do a bunch of math to figure out how to like draw paths and render glyphs.
So you mentioned Metal, and we're going to talk about Metal later in the show because I think it's important to dive into how you implemented Warp in Rust and how you use Metal on Mac OS. Before we do that, can you give an example of what a terminal would be like if it didn't use the GPU? What would we forego if Warp didn't use the GPU?
So I'm winging it here slightly because I haven't built a non-GPU based terminal. But what I think you would do instead is you would use a set of higher level UI libraries where you would do things like, it could be like a vector style API, like you could be drawing lines and curves. You could be telling it to print out text directly. But ultimately, like there wouldn't be such a clean set of graphics programs that there would be a lot of processing on the actual CPU to figure out where the pixel should be painted on the screen. I'm trying to think of a good example here. Like if you were to do this using like just the straight up Apple APIs, I don't think that everything would be graphics except like GPU accelerated, meaning like if you're to use like an NS view and an NS label and like those sort of higher level UI components, I don't think you end up with a GPU accelerated thing all of the time because there's a lot of intermediate processing on the CPU in order to figure out how to render everything.
Okay, so that makes a lot of sense. It sounds like overall, when Warp uses the GPU, I'm going to see that my terminal window has like a better frames per second.
Yep.
Okay, it's going to reduce the load on my CPU, which can be used for other things. So overall, it sounds like using the GPU gives me a better experience as a user of the Warp terminal window.
For sure.
Okay.
Those are the exact two benefits that you mentioned. Yeah.
So what I'd like to do now is to turn our attention to some of the innovative ways in which Warp uses artificial intelligence. I learned that Warp integrates AI directly into the terminal. My big question is, what in the world does it mean to integrate AI into a terminal window?
It's a great question, and I think it's an important question because of the amount of hype there is around AI right now. But in the terminal, it's actually super, super useful. So for us with AI, there's sort of two main ways of interacting with it. The first way is like it allows you to go from natural language to a command. And so this is super useful. So it's like, say I want to write a command that allows me to find all Rust files greater than 100 lines long and then extract a certain term from them or something like that. I don't know how to write that command. I could Google, I could leave the context of the terminal. I could ask a friend maybe who like knows the way it works better. But the easiest thing by far is to just ask the terminal, hey, this is what I want to do. Can you help write the command for me? And like more often than not with these large language models, the command that comes back works, which is incredible. So you go from a very obscure like way of like expressing your intent, which is these, the commands, instead of having to actually write them out like that, you can simply just say in natural language. So that's one entry point, one I think very cool way of using it. The second one is like a more conversational mode. And so this is more similar to, how you might use ChatGPT, Bard, or another one of these like LLM chatbots. The thing that makes it super useful in the terminal is the integration with command inputs and outputs. So for instance, if you run some gcloud command and it produces some permissions error and you're like, oh no, what do I do to fix that? Like it's trivial in Warp to be like, okay, let me ask Warp AI, how do I fix this thing that went wrong? So you can go right from an error to a conversation about how to fix it. And that conversation will often produce new commands. And those new commands you can directly run. And so you have a very tight feedback loop when you're trying to figure out how to solve problems in the command line. And so it's kind of an awesome use case for it. And like it's made even better by the fact that these LLMs they speak text and the terminal speaks text. So it's very simple to go right from terminal input output into the LLM and back. And then these LLMs, they're often trained on a lot of sort of command line data. Like if you look at Stack Overflow and look at the internet, there's a ton of training data around API documentation on how to actually use these tools better. So it's a really good application of technology for making the command line better.
So what you're saying sounds really compelling, and I see what you're getting at. Because of the fact the terminal window is text-centered, and these AI large language models are also text-centered, it's really cool to pull those two things together inside of the Warp command line terminal.
Absolutely. It works really, really well. Like we survey users about it. They're like, this is, pretty game changing. And it's like, it just saves a whole context switch and lets you get to the answer that you want faster and with like less of a headache. And the conversational stuff is extra cool because it remembers the context as you build up a conversation. So if you can be like, it knows that I'm trying to achieve some task in gcloud, it can use prior questions to inform the next answer that it gives. It's very powerful.
Can you tell us a little bit about how you actually implemented Warp AI? What are you using to create this powerful feature?
Yeah, so right now Warp AI is built on top of OpenAI, their ChatGPT model. And so the main like challenges on our side were like, how do you engineer the prompt correctly so that you get back meaningful results for the command line? How do you find the right integration points into the UI for the AI? And so, you want to balance making it discoverable and making it useful with like, you don't want to annoy people. Like you don't want like the Microsoft Clippy thing. I don't think, at least, like maybe that was before its time and the right way to do it. But it's like, I don't think you want like AI things popping up everywhere in the terminal, especially since like it's a tool people like do a lot of focus work in. And so you have to balance those things. And then a third thing for us is like, you really have to balance privacy and security. So it's like, our AI at the moment, you have to opt in to use it every time you want to use it, just because a lot of private information flows through the terminal. And currently, the model is not a local model, which it would be interesting to see if we could get to a local model. But the model is a cloud based model. And so we want to be very careful, people being clear if, like, hey, this information is being sent off the terminal, people should know that and choose to be doing it.
So you mentioned that right now you're using a cloud-based model. Can you give us a concrete example if I have a compiler error, or if my program crashes, or if it produces output that I think would be wrong? How can Warp AI help me in those types of circumstances?
Yeah, so compiler error is easy. This is a great example of how some of our features tie together. So say you try to compile and you get a compiler error. And so let's say that error then would be contained in one block. And so we know that the block has an error code in it. And so that you can go right from the block to something called Ask Warp AI. And so you just, with a keyboard shortcut or a click, you're like, hey, explain this error to me. And then Warp AI comes back with like this is what the error means, and here's a suggested fix. So that's one concrete use case. Another concrete use case is less around writing code and more like doing something in production. And so like a real thing that I tried to do was I wanted to figure out how to access logs and tail logs in the terminal from one of our production servers that's running on G-Cloud. That's not a one command thing. That's like first I need to list all the instances, then I need to find like the name of them, and then I need to make sure I'm like correctly set up to access things through the firewall. And so it will do a guided sequence of commands with you to get you to the right point, including answering like, well, if you run a command and it's like that instance doesn't exist, it will try and give you ideas on how to debug getting to the right thing. So super powerful for those types of production use cases.
Yeah, I can imagine that that would be incredibly helpful for me as a developer. Can you comment quickly? If my program crashes and there's a stack trace in the terminal window, can Warp AI help me to understand that stack trace?
100%. Yeah. So you just go ask Warp AI. And if you want to ask a particular, you can either just be like, tell me what's going on, or you can ask a particular question like, why is this having a null pointer exception, or why did this seg fault, or, and like it will do its best. Now I will say the AI models have limits, and they are prone to hallucination sometimes. So it's like, use it with care. Like I've had situations where it will refer me to documentation websites that don't exist, or like confidently tell me to do something that isn't quite right. So I would certainly like use your judgment, but as an aid to solving things quickly, it's a phenomenal technology.
So a moment ago, you mentioned the idea of using a local first model. Before we talk about the local first approach, I wanted to clarify one quick issue. Is Warp AI actually sending to the cloud the source code of my application, or is it exclusively using the text that it sees in the terminal window?
It's exclusively using what you directly give it on a per invocation basis. So there is absolutely no background sending of someone's context or data in our current implementation. Now, that said, I actually think the AI would be significantly more powerful if we were able to provide more context, but we've taken a very conservative approach, again, because of like privacy and security concerns. So right now, to answer your question, it's like you can see in our sort of input area exactly what's being sent, and there's no more than that being sent.
Okay, thanks for clarifying that. Let's dive into the idea of a local first model. What is a local first model, and what are the trade-offs associated with using it either as a substitute for a cloud-based model or perhaps in conjunction with a cloud-based model?
Yeah, so local first just means like we wouldn't be using the network at all to sort of generate suggestions or AI responses. There's different ways that you can do this. The sort of trade-offs I think are in terms of like model size, sophistication, disk space, like resources to run the sort of inference step. And so then there's also like on the plus side, there's increased privacy, security, like you have confidence stuff's not leaving your computer. It works even if you don't happen to be connected to the internet, which is, like something that Warp we generally strive for is Warp should always work. Like you shouldn't have to have an internet connection to use your terminal. Like we want graceful fallback with that. But today it's like you need an internet connection to use Warp AI. And so, I think there could be benefits around latency as well. Like right now we have, network latency, although I would say most of the actual latency is in the inference, like the actual like performance of the prediction on the model side, not the network. But having a something that's local could be really, really good, especially for super highly latency sensitive operations. So like, for instance, if we wanted to do something like predict your next command as you're typing, that's a very latency sensitive thing where you don't want 3 seconds to pass as you're typing to get the prediction. You want, sub 100 milliseconds worth of latency so that it seems like it's just happening in real time. Those are some of the trade-offs.
Yeah, what you're saying makes a lot of sense. Ultimately, are you considering some type of hybrid approach where sometimes you use a cloud-based model, other times you use a local model? What's on your roadmap, Zach?
Yeah, so I mean, we want to work backwards from like what's going to be best for users. Yeah, it could be some sort of hybrid. It could be that, even there's a third option, which is like a self-hosted model for organizations that's cloud-based, but not on, using OpenAI's public APIs. And so there's a lot of different ways that we could do this. And I'd say we're still very early on. We launched our first iteration of this about 2 months ago, and it's something new is happening in AI every single day. We are actively trying to figure out what's going to be the best user experience. And that's ultimately what's going to drive it. Yeah, it could be some hybrid.
Thanks for the insights that you've shared about how you use AI in Warp. I think you mentioned a really good point, which is you want a terminal window that's best for developers. And obviously, you made a decision to implement the Warp terminal window in Rust because it was going to be best for developers. Can you share a little bit about the key features of the Rust programming language and why you decided to use Rust for your implementation?
Sure. So Rust is a great language. I think you typically call it like a systems language. It compiles down to binary. It is, I don't know, I'm probably going to not describe this in a way that Rust enthusiasts like, but it's almost like the next generation, safer, more ergonomic version of C++ in a lot of ways. It's not really object oriented in the way that C++ is. Some of the benefits are produces very fast code. So that was, again, like we're hyper performance focused, produce very fast code. It does this by sort of like a unique memory management model where in Rust, there is like a concept of like ownership of references and sort of moving references that is very different than in most languages. And, Rust consequently is not a garbage collected language. So there's no overhead of a garbage collector. It's also not a sort of manual memory allocation and freeing language. So you don't have a lot of the issues that can cause, sort of memory safety errors or seg faults or that type of stuff that you get in C++. It has its own very unique model of like who owns what value. And as a programmer, it actually, I would say it takes like a fair amount of getting used to, like something that, you expect to be like an assignment operation is often more of a move operation in Rust where you're moving ownership. And so you do spend more time, I'd say, fighting the compiler than you do in most languages. But once you learn it, I think it's actually a very ergonomic language to work in. It has great community support and it has great cross-platform support, which is another really, really key thing for us. So, you can compile Warp apps for most platforms, including the web platform, which is, I think maybe we'll talk about this in a bit, but it's a platform that we really care about supporting at Warp. And so I would say of all of the languages, maybe besides TypeScript, but maybe even better than TypeScript, Warp has a compilation to WebAssembly, which is a path that we want to use to bring Warp to the web. And so we've had an awesome experience using it. It's a great programming language.
So we'll talk about using Warp in the web browser in a moment. It sounds like one of the things that you're saying is that there's a learning curve associated with Rust, but if you want to make a high-performance terminal window, Rust is a really good language to pick.
I think it's the best. I would say for a combination of high-performance, multi-platform, it's the best option. The other big multi-platform option is the common option is to build it in web technology. We prototyped Warp as an Electron app using like TypeScript, and the performance was far worse. Like you just start at a sort of like performance debt is almost how I would say. Like you pay for a lot of the overhead of what browsers are built to do, which is not like high performance viewported like terminal rendering. And I know this also from my time building Google Docs, like which has a lot of the same sort of performance challenges. I wish that we had used something like Rust and Wasm to do it, because it's just very, very hard to get optimal performance out of JavaScript plus the DOM. And so those were the reasons why I went with Rust.
Yeah, what you're saying makes a lot of sense. I remember earlier you mentioned that you use Metal, which is the macOS GPU API. Can you talk a little bit about how Rust and Metal work together in the Warp command line terminal?
Yeah, so the way that we use Metal, so Metal is a set of graphics APIs that let you access the GPU on Macs. And the sort of language that Metal works with is a shader language for Metal. So like if you're writing, Metal shaders, it kind of looks like you're writing shaders in OpenGL or WebGL. You're writing fragment shaders and you're writing pixel shaders and you're writing things that go into like the graphics pipeline. And so that's not written in Rust. That's written in actual Metal shader language. What we do with Rust is we have a sort of platform abstraction where we've actually built our own sort of, lightweight UI framework, where if you want to be able to say like, okay, give me a rectangle that has text inside of it with rounded corners. You don't have to like go all the way down to the shader code to do that. Like that would be insane to write. You write it, and what we do is we construct a scene, and this all happens in Rust. The scene goes down to a set of primitives that map one-to-one into the shader language. And it's actually very few primitives. It's super cool. So all you really need to render a terminal is the ability to render like a rectangle. And that rectangle can have borders, backgrounds, rounded corners, that type of stuff. You need to be able to render glyphs. And so like the text rendering is one of the more complex parts of our rendering pipeline. And you need to be able to render like images and icons. And that almost honestly gets you everything. Like those are the primitives. And so what our Rust-based UI framework does is essentially translate higher level things into those, what ends up being a sequence of graphics calls to draw recs, glyphs, and images. And so, you go from Rust into those graphics calls. The graphics calls have to actually happen like Objective-C, because there's Rust allows you to sort of do something like, I think it's the foreign function interface. It lets you bind into native platform code selectively if you need to. And so, 95% of our app is Rust, but the pieces that are like, hey, we need to call, Metal, we need to actually do that from Objective-C. And so you bind in the native code to do that.
So thanks a lot for giving us the overview of how Warp was implemented using Rust and using Metal. One of the things that I can tell really clearly is that performance is central to your work. So my question is, how do you make sure that when you ship a new version of Warp, that you've maintained your performance goals?
It's a great question, and it's really hard. I'd say there's like a few general approaches. So one approach is benchmarking. And so, we have a sort of suite of benchmarks that we can run against Warp and make sure that we are, performing well, at least against other terminals. We're in terms of like where we're at with that, it's like we're not necessarily the fastest terminal on the market for every single operation, but we are a very fast terminal, like for most operations. And so that's the way we compare to the competition. The other thing is harder is like regression, like preventing regressions in performance. And so, there's different approaches I've used in my career for this. What we use at Warp right now, like we don't have an environment in which we can consistently like get like sandbox performance data. So we tend to use more like looking at actual stats of Warp performance in the wild, which is gives you okay view in the aggregate, but it has several problems. It doesn't give you like a way of preventing a regression until it's live. The ideal thing that I've actually did at Google, which is not a thing that's easy to do, or at least I haven't found a great solution, was having a suite of performance tests that could run, and you could run them as part of your continuous integration to make sure that you're not regressing things. Very, very hard because there's a lot of noise, and you need like a very controlled environment to get like sort of accurate regression tests. But yeah, those are the different ways that I can think of.
Thanks for sharing all of the ways in which you're using Rust to implement the Warp terminal window. I know that ultimately your goal is to ensure that Warp can run on Mac OS, Windows, Linux, and ultimately the web. Can you tell us a little bit about the steps you're going to take to make Warp work in all of those locations?
Yeah, we're working on this right now, actually. So Linux is our number one requested user feature. We're fortunate in using Rust that all of the non-platform specific parts of our code will basically just compile for like Linux and Windows. For the web, it's trickier because there's some sort of like threading and async primitives that we use in Rust that don't like translate that cleanly to the web execution model. So it's taking a little bit more work to sort of do a platform compilation for web. But for the most part, the Rust code will compile. The pieces that are platform specific tend to be harder. And so that is like text rendering, like getting like the actual like glyphs is a platform specific thing, and getting the text shaping and all the like text metrics that you need to actually lay out text, because we depend on the OS to tell us how to do that. Windowing, like different platforms have different sort of windowing primitives that we need to hook into. The event loop, so different like OSs will emit different types of events. And so we have a platform abstraction in our code that lets us like, basically like know when we're leaving like the shared code into the non-shared code, into the platform specific code. But that's basically the work of it, is like, first you got to get the Rust to compile, and then you have to fill in all of the platform specific pieces. And then I guess the final thing is like, these different platforms have different distribution mechanisms and packaging mechanisms. So like, for Mac, it's DMG and Homebrew. For Linux, it's building for a bunch of different like Linux distributions. For Windows, I don't know. We haven't looked closely. And then obviously for the web, it's like serving Warp as a big, WASM/JavaScript bundle that gets downloaded. So we have to figure all that out.
So it sounds like you have a lot of work ahead of you. Can you give us one concrete example of how someone would use Warp on the web? And how would it be similar to or different from the way they use Warp on their Mac OS desktop?
The big sort of product innovations that we're trying to bring to the terminal is to make it work not just for individuals, but for teams. And so one of the features I talked about earlier, like the ability to like take a block, get a link to it and share it to people on your team, is the start of that. But there's more to it. Like we would like to be able to actually not just share a block, but share an entire session. And you can do that, we could build that within the native app so that if both people have the Mac app installed, they can, share the session in the Mac app. But I think it's actually a more powerful primitive to be able to let people to open up a terminal session in their browser, especially if that terminal session is fast and has all of the Warp features, which is what we're building towards. And so terminal session sharing is one example. There's other examples around knowledge sharing, where it's like you want to be able to link to terminal documentation and have other people on your team use it. We are, I think by the time this podcast comes out, we'll have launched an actual feature in Warp that is a sort of multiplayer feature where people can store and share terminal commands and soon notebooks. And so all of that stuff, all these sharing features, I think are much more powerful in the web. The second thing is like, I do feel like the world of development will eventually move from being just like development on your local machine to, primarily development on remote machines. I think it's going to take a long time to get there because people's setups are so complicated and there's actual advantages to being local. But in a world where you're not developing on your local machine, it's actually, there's a lot of advantages to having a web-based rendering. It's like you can look at the thing from your phone or from your laptop or the web does give you a lot of benefits, and we're trying to position ourselves to take advantage of those.
Yeah, I can imagine it being really compelling to be able to use Warp locally. And then when I want to loop in some of my colleagues on my team, I can have them work with me on Warp running in my web browser.
Exactly. Like we feel like that's potentially such a cool killer use case, whether it's for teams or for classes or, for people doing firefighting, to just have a one common view like you have in something like Google Docs. I think it could be transformative. And so the web, it's not strictly necessary for that, but it makes it so much easier and better.
So at this point, we've covered many of the basic and advanced features of Warp. And I think you've done a really great job of sharing those exciting ways in which we as listeners of Software Engineering Radio can dive in and use Warp. Are there any features of Warp that we didn't talk about that you would like to highlight?
I mean, the one that I was going to call out was this thing called Warp.dev, which will be launched by the time this is out. I'd love for anyone who is using Warp in a team setting to try it out and give us feedback. It's a totally novel thing where it's like, hey, I have, these 5 commands that I use to talk to G-Cloud, which could then be shared with your team and you could all use them. So I'm super interested in any feedback on that. Other stuff, I don't know. We have some really cool stuff around theming. That's always a lot of fun. People can go in and play with our themes, and we have a community-oriented way of people submitting themes. So if you want to, make a theme for us and share it, that's always cool. But no, I think we covered most of the cool stuff.
So that's awesome. As we're drawing our episode of Software Engineering Radio to a conclusion, I want to turn to you as an expert both in using a terminal and also in developing and shipping a terminal. Can you give a call to action for our listeners when it comes to terminals or developer tools or the Warp command line terminal in specific?
So I'd love for folks to try Warp and give us feedback, obviously. I would say if you're a developer who's not much of a terminal user or who's been intimidated or turned off or just not wanted to bother with the setup and headache of getting a good terminal environment, I would, I would give terminals a try because I do think there's huge productivity gains for people who really know how to use them well. I would say Warp is probably the easiest way to get in, or at least that's our goal, is to make it the easiest and most powerful experience. But I don't know, I'm a really big fan of the command line as a way of increasing your productivity and increasing your skill as an engineer. Most of the best engineers I know, they do stuff in the command line that feels like magic to me, and it saves them a bunch of time. So my pitch would be give it a shot and spend some time learning the command line, because I think it could really up your game as a developer in general.
All right. Thanks for that call to action. Is there anything that we didn't talk about in this episode that you'd like to share before we draw things to a conclusion?
I don't think so. I would just say I know there's probably a lot of great engineers listening to the show. We work in Rust. If you're interested in how do you help developers ship better software more quickly, if you're interested in terminals, we'd love to hear from you. And all of that information is on our website, which is Warp.dev, which is also where you can download and try out Warp.
All right. So this has been an awesome conversation. I've really been keen to learn more about Warp. I hope that people will try Warp out and get in contact with you. If anyone wants to learn more about Warp or the way in which Warp was implemented, they're welcome to check the show notes for this episode to catch many of the details that Zach and I will pass along to you. Zach, thanks for being here on Software Engineering Radio.
Gregory, thank you so much for having me. This was fantastic.
All right. Thanks for being here, Zach. This is Gregory Kapfhammer signing off for Software Engineering Radio.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.